2.4 part 2 is on the derivatives of exponential and log functions. So we're learning some new derivatives today. So if you remember from Algebra 2 and pre-calculus, we have these different rules for exponents. So if I have a to the x times a to the y, it's a to the x plus y. You add your exponents. This is going to be a to the x over a to the y, so it's a to the x minus y. A to the x raised to the y is going to be a to the xy. And a times b raised to the x is a to the x, b to the x. You can bring the exponent in. Okay? So if we have the graph of f of x equals e to the x, this is a very special exponential function. Okay, at this point, 0, 1, the slope is 1. At the point 1, comma e, the slope is e. At the point negative 1, comma 1 over e, right, e to the negative 1, the slope is 1 over e. What do you notice about the slopes? Exactly. So this is kind of an interesting function because as you look at the slopes of each of these points, right, along here, it gets steeper and steeper and steeper as you go up. The slope ends up being exactly the same as the y value. So it's the only graph where the slope is the exact same. So the slope is the same as the y value. So e to the x is its own derivative, basically. All right, so that's what it says here. So the derivative of e to the x is itself, e to the x. Now, don't get all excited. If you have y equals e to the 2x, for example, what is that derivative?
Bring down this 2.
You'd have to do e to the 2x again, right? It's itself, but then you have a chain. So times 2. Is that what you mean by bring down the 2? Yeah. So yes, you have the derivative of e to the x is itself e to the x. But if you have something other than x or u or t or whatever, you're going to need to do the du part. So you need the chain rule.
So does it come out of the 2x and like t?
Exactly. So it's like inside. Yeah.
Is it still raised to 2x?
Uh-huh. It's just the same thing. So like if you had the derivative, so if you had e to the sine of x, oops. The derivative of e to the sine of x is going to be y prime equals itself e to the sine of x times what? Cosine of x. You need the chain. Oops. What's going on here? All right, so number 1. So it says differentiate the function. Okay, do you guys recognize that we have product rule on that? You should be getting used to this.
No, shouldn't it be sine x minus e to the...
No.
No.
So you guys are getting it confused with x squared. X squared, its derivative is 2x to the first, right? Or x to the fifth is 5x to the fourth. You cannot use the power rule when you have e. E is a number. Right? If I have e to the x squared, its derivative is going to be itself e to the x squared times the chain 2x. You can't say it's x squared e to the x squared minus 1. You can't do the power rule. The reason is because this is in a different form. It's not x raised to a number. It's a number raised to something with x. We're learning something new. Do you guys understand what I'm saying? So if you ever have like an x raised to a number, like x to the pi, yes, its derivative is pi x raised to the pi minus 1, right? But we don't have x raised to a number. We have e, which is a number. Yes.
Is it just e to the square, or if you like x raised to the 3x? Does this rule apply?
X raised to the 3x? That is something else. Yes. All right, so here we go. So I have x squared plus 5x times e to the x. So I need product rule. So I'm going to have f prime of x equals first, so I keep it the same, times derivative of the second. So what is the derivative of e to the x? E to the x, exactly the same, plus derivative of the first, so 2x plus 5, times the second normal, e to the x. So on these problems with e to the x, when you do product rule or whatever, you're going to have an e to the x that's going to pull out. You guys see? They have a common factor, e to the x. So when you do that, you have x squared plus 5x plus 2x plus 5 left. You can put them in parentheses if you need to see it that way. You can see how I pulled the e to the x to the front. So you get e to the x equal, or e to the x times x squared plus 7x plus 5. That's f prime. Okay, same thing on the next one, only now we don't have product rule, we have quotient rule. G prime of x, low, d high. Derivative of high is e to the x. Plus, or minus, ooh, could have got a modus point, minus high, d low, all over the square of what's below. Okay, do you guys see on quotient rule, you also have an e to the x. So you pull out the e to the x. When you do that, you have 1 plus x minus 1 all over 1 plus x squared. So you get e to the x times x. So I usually write that as x e to the x all over 1 plus x squared. That's your answer. All right, next up. Now we get some hard ones. Some doozies, right? Mm-hmm. Do you see this next one has a double chain? You look worried. All right, so this inside part, we're treating that like a u. So what if I had y equals the square root of u? Its derivative would be what? Exactly, because square root of u is u to the 1/2 power. So we bring the 1/2 to the front, u raised to the negative 1/2. Okay, so we're going to use that in here somewhere. So I'm going to have y prime. So this is really in the form square root of u. So I'm going to have 1/2 my u value raised to the negative 1/2. Right, so this is the u part. And then I need to tack on a du. So the derivative of u. Now remember, u was the inside part, 1 plus 3e to the 2x. What is the derivative of that inside part?
3e to the 2x times 2.
3e to the 2x times 2, yes. That's that. So it was a double chain because that times 2 part was the chain for the 2x. Does this make sense? You guys see all the inner u's.
So do you want us to simplify that system, or?
You can a little bit. I would probably cancel the 1/2 and the 2. And then I would rewrite it as 3e to the 2x on top. And then on the bottom, do you guys see how since you have raised the negative 1/2 power, a negative 1/2 power means 1 over a square root. So 1/2, or not 1/2, so square root of 1 plus 3e to the 2x, like that. So I'd probably simplify it so it looks like that. Okay, the next one. Ooh-wee. Lots of chains on this one. Let's see if we can do it. So first I'm going to rewrite, so I see it's sine of e to the cosine t, everything squared, right? Because that's what the sine squared part means. It means the sine part is being squared. How many chains? 3, that's right. Do you see them? So you have an e to the u, right? That's the first u. You have a sine of u. You have a u squared. So you're going to work from the outside in. So the first thing you start with is u squared. So we start with u squared, right? So all of this in here is my u. So u squared, what's the derivative of u squared? 2u. So I'm going to have 2u. So I write exactly what the inside part was. You could write to the first if you want, but you don't need that. Times du. So my du is going to be the derivative of sine of e to the cosine t. So that's in the form sine of something, sine u. So what's the derivative of sine u? Cosine u. So it's going to be cosine of that inner part, e to the cosine t. So now I need the derivative of the u for that part, right? Sine of u du. So now my u is here. So you're going to have e to the cosine t times negative sine of t. Ooh, that's a lot of chain rule. Really, the only thing you can do to simplify this is you could bring the negative up front. There's not much. I mean, it's all just being multiplied. So that would be good. You guys want to try one more? Let's try an e. So let's do y equals cosine squared e to the x over x. So I always rewrite first when I have like a cosine squared. So I'm going to have cosine of e to the x over x. All of that's being squared. So I have u squared is my first form. So y prime is going to be 2u. Then I need du. So what's the derivative of the cosine of e to the x over x? So cosine of u gives me negative sine of u. So I'm going to have negative sine of e to the x over x. And then I need my du. So what do I need to do for du? Quotient rule. Low d high minus high d low all over the square of what's below. So you're going to get 2 and negative, so negative 2 cosine of e to the x over x sine of e to the x over x. How's that other part simplify? So times e to the x minus 1 in parentheses over x squared. That's all you get. All. That's all. No big deal.
Oh, only that? Oh, okay.
Oh, no big deal. A plus. All right. You guys understand what we're doing here? Do you need to see any more? Maybe. If one person says one more, I'll do one more. One more. Blame Taylor, not me. All right, so let's make an F. So what if I have y equals e to the 3 cosine of x? Let's mix it up. Cosine squared x. Oh. Okay, so think through. This is in the form e to the u. So y prime would be itself e to the u times the du. So remember, you're thinking of cosine 3 cosine squared x is 3 cosine x squared. So when you do du, what do we get? 6 cosine x to the first, right? Times, this is the u. Oops, negative sine of x, exactly. All right. We okay? You could, yeah, in the 6. I'd probably write negative 6 e to the 3 cosine squared x, cosine of x, sine of x. I'd probably write it like that, but it doesn't matter. Okay, let me go back up. Why is it so tiny? All right, so the motion of a spring is described by f of t equals e to the negative 2t times sine of 3t. Compute the velocity at time t. So can I erase that last problem I just did? I'm going to erase this. Okay. All right. So f of t, so this is the position. Right, it says the motion of the spring, so the location basically of the spring is given by this. Yeah, you guys have it on your page, right?
Yeah.
All right, so f prime is going to be my velocity. So do you guys see we have a product? E to the negative 2t is part of it. Sine of 3t is the other part. So two functions multiplied together. So I'm going to have e to the negative 2t times the derivative of sine of 3t. So sine is going to be cosine of 3t times 3. Because I'd left that part normal to begin with. And then plus, now the derivative of e to the negative 2t is e to the negative 2t times negative 2. And then sine of 3t. So I did product rule. Okay, and really all we can do is we can pull out the common factor. So it's e to the negative 2t. And we're going to have 3 cosine of 3t minus 2 sine of 3t. And you put the 3t's in parentheses if you want. You don't need them though. Okay, so that's the velocity function. So we're going to go ahead and graph that. So get out your calculator, we're going to graph it. So I'm putting this in for y1. And we kind of played around with the window in the last class, and we found the window, if you had x from -5 to 5 and y from like -3 to 3, it wasn't too bad. It worked out okay. So we did all the hard work for you. Actually, I lied. Let's do 0 to 5. Because we're not worried about negative time, right? So let's do 0 to 5. So you end up getting a graph that looks like this. It comes down, it dips below the axis, and then it goes a little bit above, and we don't really know what's happening there. Okay, so it's going a little bit above. Do you guys have that? Make sure you're in radian mode. On the left side, it ends up like over here. It like bounces up and down, up and down, up and down. But we're not worried about that stuff, right? Because it's negative time. Okay. So the question asked, when is the velocity 0? So we're going to find this point right here. We're going to find this point right here. And then we're going to see if there's any other point where it's equal to 0. Okay, so we're going to do second trace 0. And we're going to get on the left side and the right side of that first one. So the first one on the left. So enter, get on the right side, enter, guess, enter. So Annie, can you kind of help Han with this too? Yeah, okay. So this first 0 is 0.3276, somewhere around there. I always store any values I find. So usually when you find something like when is the velocity equal to 0, that's important for your problem. Think about that. Why would it be important to find where the velocity is equal to 0? What's happening to the object? It stopped and then it changed directions, right? So in this case, we were going in a positive direction. We were up above the axis, so v was positive. And then we were below the axis, so we went backwards. Okay. So what I do to store, so this is important. Other class had trouble with this. So go back to your main screen, so do second quit. And hit X T theta N, so that little button X, hit the X button. Enter. Do you guys see how your number comes up? Yes. Okay, we're going to store that number. So we're going to do STO, S-T-O, and store it as alpha A. And whenever I do that, I write above it that I've stored. So I do A and then I circle it. Because that may become in handy later, we never know. All right, now let's find the next one. So do the same process. So find the 0 for the next one. So left bound, right bound, guess. This other point is 1.3748. All right, now I'm going to store that as B. So go back to your main screen, hit X, store as B. I'm going to teach you my favorite Zoom feature. I'm a math nerd. I have a favorite Zoom feature. I'm going to teach it to you right now. You ready for this? It's very exciting. All right, I can't tell what's happening on the graph, but from my graph, it looks like it goes a little bit above. So it's like, does it go back down? Now you could trace along the curve, right? And you could see probably that it goes back down. Mine kind of takes it back, but it looks like it does go below the axis if you're tracing. But if you really want to know what's happening, you can use zoom box. So you go to zoom. It's the very first option, D box. Okay, and D box is really cool because it allows you to zoom in on any part of the graph that you want to know more information about. So what I'm going to do is I'm going to take my cursor. So do you guys see, like I'm pretending I have a cursor. I'm going over here. I'm going to go like right here. And then I'm going to go down. And then I'm going to go over. And you're creating a box. So you're going to go up to, I went kind of high, but let's say like right here. You guys can't see my color, can you? So right there, and hit enter. And now it's flashing. Do you guys see how it's flashing? Arrow over. So if you arrow over, it's creating like just a straight line over. And then arrow down. So don't hit enter, but arrow down. And you've created this box. Do you guys see how it opens up and creates a box? Once you get the box that you want to zoom in on, so you might make this a little bit wider, so go over a little bit more. So it takes a while for it to go below the axis. Then hit enter. It doesn't matter. Just create the box. Yeah, you have to form a box. It can't just be like a straight line up and down or a straight line over. So you have to move right and down.
Oh, right and down.
Or down and right. Either way. So when I zoomed in, here's what my zoomed in picture looks like. It goes up, and then it goes back down. So I can see where it's crossing. So that's my other 0. I need to find that 0 right there. So second trace, 0.
Not
Is it making a
no, it keeps coming up with zoom error. Or zoom error zoom.
Like, don't press enter before you keep moving through.
Oh,
Right and then down.
that's it.
I even said that, man.
And
All right, so this last one is going to be 2.42199. So that's going to be C. So store that as C. Yeah. Yeah, because on the left side, and I told you guys that, like on the left side it's oscillating. All right, we're not worried about negative time, right? We're not going back in time. So start at 0. So yes, it is jank on the left side. Yes. All right, do you have 3 values? Okay, last step. So it says, when is the velocity 0? So we found those 3 places. So velocity equals 0 at, you can just write A, B, and C, because you named them. What is the position of the spring when the velocity is equal to 0? So we need to go back and find f of, oh man, keep hitting extend page on accident. So f of A, f of B, and f of C. Now you can do this very easily. This is another calculator trick. It's very exciting. So you're going to go to y equals, and for y2, plug in your f function. So it's going to be e to the negative 2t times sine of 3t. Now the other class had trouble with this. Make sure you put parentheses around the negative 2t. Unless yours is fancy type and it just raises it so you can see it. And you have x's, right? E to the negative 2x sine of 3x. So you're putting it in for y2. I can tell you all are sleepy today. Got to case the Mondays.
it's a big Wednesday though.
Go all the way down. Okay. All right, so back to here. So we're going to go to table, the second table. So in your table, you can see x and y, or you can see x, y1, and y2. Do you guys see all 3 columns, x, y1, y2? And you're going to put in A, B, and C. So do you guys have it so you can adjust the values in your table? Like it's set so you can put whatever you want. If you don't, you can go to table set and change it. So if your neighbor knows what I'm talking about, they can help you. All right, but in here, I'm going to do alpha A, enter, alpha B, enter, alpha C, enter. Now, Y1's all giving me 0, right? That was the block one. That makes sense. We just found when it was equal to 0, right? But Y2 is giving me the position at those points. If you need to arrow over to see more digits, you can, but it's 0.432, negative 0.053, and 0.007. Okay, 3 answers. Those are the positions. All right, so we're good on that problem? So we completely solved that. All right, now for the next one. So find the absolute maximum value of the function f of x equals x e to the negative x. So pretend we don't have our calculator. We need to do this all without a calculator. It's gone. You could just graph it and find the maximum, right? Not very exciting. Uses no calculus whatsoever. Okay, so we're going to use our calculus skills. So in order to find a maximum, think about a curve. If I'm finding the maximums or minimums, that's where our tangent slope is equal to 0, right? This one I kind of missed. Just draw a big point. All right, so we need to find when our tangent line has a slope of 0. So we're going to do that by finding the derivative and setting it equal to 0. So I'm going to find f prime of x. So f prime of x is first times the derivative of the second. So what do I get for the derivative of the second? Times negative 1, right? So negative e to the negative x. So e to the negative x times negative 1. That was from the chain. Plus first derivative of the first is 1. Second normal is e to the negative x. So we end up getting e to the negative x times negative x plus 1. Right? We pull out the common factor, which was e to the negative x. Like I said, we need to find when the tangent is equal to 0. So I'm going to set it equal to 0. Okay, so I set both pieces equal to 0. But if you notice, e to the negative x, that's 1 over e to the x. 1 over a number is never equal to 0, right? It doesn't make any sense, right? 1 over something. That's never equal to 0. So this is never 0. And if it had just been playing like e to the x, it's never equal to 0 either. Okay. All right, so then I have my negative x plus 1. Well, that could equal 0. So x equals 1. So at x equals 1, something is happening. So what we do is we put it on a number line. Now, on your AP test, you have to describe everything that you do on this number line. So it's kind of annoying. You need to write out what's happening on this number line. The reason is because 90% of calculus teachers use this number line, but the 10% that do not use it use a weird table that I learned when I was in school. Okay, so if you do the weird table, you would need to describe that as well. So because of that, they make you describe it. So I'll kind of explain what you would need to say. All right, so let's say we plug in something less than 1. These are critical values, just like algebra 2. Remember, we did these before. All right, so if I plug in 0 into the derivative, so here was the derivative. If I have f prime of 0, I'm getting e to the negative 0 times negative 0 plus 1. E to the negative 0 is still 1 times 1. All I'm worried about is that I get a positive number in the end. All right, then try something on the right. So let's try 2. If I have 2, I have e to the negative 2, which is 1 over e squared, times negative 2 plus 1. So 1 over e squared is positive. The second part is negative. So I get a negative number, and you can check it on your calculator if you want. But like I said, this should be a non-calculator one. You should know how to do this without. Okay, what we have determined is that on the left side of 1, we are increasing. Right? F prime is positive, so that means your slope is going up. On the right side of 1, your slope is going down. So at 1, since your slope is equal to 0 at 1, we have a maximum. Does this make sense? So on the AP test, so we'll do a ton of these later, so you don't need to write it now, but we would say something like f prime is, so you'd say f prime is less than 0 on negative infinity to 1, f prime is greater than 0 on 1 to infinity, therefore f has a max at x equals 1. So you would write all that out. You don't need to do that now. Does your arrow need to cross the line? No, it's just I ran out of room because of that little thing. I didn't want to take video of myself. All right. So, so that means we have a maximum. Now it says find the maximum value. All right. When you say maximum or minimum value, you're saying how high or low does the graph go. So you need to find the y value. That's just where it's located. So at x equals 1, right? So we're going to say max of something at x equals 1. So we find it. So go in and plug 1 into your original. If you plug in 1 to your original, you get 1 times e to the negative 1. So you get 1 over e. So we have a max of 1 over e at x equals 1. That is your solution. With me?
Wait, so why did we draw the number line?
So we could tell it was a maximum and not a minimum. Because if we have some kind of curve, any place where we have a tangent equal to 0, it could be a maximum, it could be a minimum, it could even be something like this, where it's neither a maximum or a minimum. So that allowed us to show, since we were increasing, we hit a slope of 0, and then we decreased, we had a maximum there. All right, so next up, so we're going to learn what the derivative of natural log of x is. So it says, suppose we have the function y equals natural log of x. Okay, we're going to go back to our basics in Algebra 2. It says in exponential form, this equation is what? So think about it. If I have y equals natural log of x, that's y equals log base e of x. So how do you switch forms? E to what? E to the y equals x. Right, so that's how we switch forms. E to the y equals x. Okay, I'm going to show you where this formula comes from. So back in the last section, this is why we had to learn how to do implicit differentiation. We're going to derive this implicitly. So we're going to take the derivative implicitly. So what is the derivative of e to the y? E to the y, but it was a y term, so dy over dx equals derivative of x, 1. So that means dy over dx is equal to 1 over e to the y. But what was e to the y? X. So that means that the derivative of natural log of x is 1 over x. We've just shown that. Okay, now that I've shown it to you, you never have to derive things implicitly again. For some reason last year I showed this to people because it's a very quick proof. This is why this is true. And then for every single natural log problem we had, they tried to derive things implicitly. Why? I have no idea. The derivative of natural log is now 1 over x. You may use that until the end of time. So don't do that all the time. Okay, so the derivative of natural log of x is 1 over x. That's what it says here. All right, so this first one, so if I have f prime of x, so remember, you still need chain rule. This is natural log of u, right? So the derivative of natural log of u is 1 over u du. So you need 1 over x squared plus 10 times what? 2x, right? That's the u. That's the du. All right, so this one is cosine of u. So in the form cosine of u, right? So when I take the derivative, it's going to be derivative of cosine of u is negative sine of u times du. So what's the derivative of u? 1 over x, right? Derivative of natural log of x is 1 over x. Good. Is this making sense? You guys like natural log? It's an easy one. How about this one? So we're going to get y prime equals 1 over sine squared x, but then I need to multiply by sine squared x. So, or the derivative of sine squared x. So I'm going to have 2 sine of x, remember it's sine of x squared, so it's in the form u squared, so 2u du, cosine x. Notice things cancel. So we end up getting 2 cosine x over sine of x, which is 2 cotangent x. Okay, I'm going to keep you 1 minute over. You're going to cry. I don't care. All right. Calculus. All right, if you had noticed something in this last one, it makes it a lot easier. So notice in this one, I have natural log of x to the 1/5. You can bring that 1/5 to the front. You guys agree? Okay, so on this, so g prime of x, I'm going to have 1/5, and then the derivative of natural log of x, which is 1 over x, right? So it's 1 over 5x. Easy. What if you had noticed that over here? Y equals natural log of sine of x squared. That's what that's saying, right? Bring the 2 to the front. So it's 2 natural log of sine of x. Now take the derivative. Don't pack up. It's rude. 2, derivative of natural log of sine of x, 1 over sine of x, derivative of cosine of x, or derivative of sine of x is cosine of x. You guys see how you get the same thing?
What is this cotangent x?
Cosine over sine. Yay, pre-calc. Remember that? Pre-calc, yeah. All right, now this one, if I'd done it the long way, it's not really that long. Don't sweat.
Do we have to know how to do it?
Yeah.
And that's what we've been doing.
Okay, so it's going to be 1 over x to the 1/5, right? Natural log of u, so 1 over u. What's the derivative of u? So what's the derivative of x to the 1/5? 1/5 x to the negative 4/5, right? So it's 1 over 5 x to the 1/5, x to the 4/5 is also on the bottom. Do you guys see how you get 1 over 5x? You get the exact same thing. You get this, 1 over 5x. You combine your x to the 1/5 and x to the 4/5, they combine to be x. All right. I have homework for you, but it's not due till Wednesday, so pass it out.